So in last class, we have seen the parametric representation of the surfaces, then how to find the normal vector when you are given the parametric representation, how to form the tangent plane, then how to obtain the area of surface as a double integral in parametric form. So in today's class, let us look at a few problems based on all these topics. So the first set of problems are on the parametric representation. So we will see how to form parametric representation of surface in different ways. So the first type of problem is to find the parametric representation of the surface in terms of the parameters u equal to x and v equal to y. So let us look at the first problem. So that is 2z minus 3x plus 4y equal to 6. So here you are given a surface 2z minus 3x plus 4y equal to 6. So we need to use the representation u equal to x and v equal to y. So we need to replace x by u and y by v. So this will give us z in terms of u and v. So we will get the parametric representation in terms of the variables u and v. So when you use a substitution, that gives z equal to, so z is 6 plus 3x minus 4y by 2. So replace x and y. So that will give z equal to 6 plus 3u minus 4v by 2. So therefore the parametric representation is u, v, then 6 plus 3u minus 4v by 2. So that is the required parametric representation. And the next problem is when you have the surface y square minus 3z equal to 6. Now again x is equal to u, y will be v, for z in the value z will be equal to y square minus 6 by 3. So upon replacing for y square by v, for v square wherein v square minus 6 by 3. So therefore the parametric representation will be uv v square minus 6 by 3. Now let us look at another example. So find the parametric equation for the portion of the cylinder x square plus y square equal to 7 that extends between the planes z equal to 0 and z equal to 1. So when you take a cylinder, cylinderന്റെ radius എപ്പോഴും fixed ആയിരിക്കും and the angle is varying from 0 to 2 pi. So നമ്മൾ cross sections എടുക്കുമ്പോൾ cross sections എല്ലാം circles ആയിരിക്കും there. So the circle have parameterization r cos theta r sin theta. അപ്പോൾ circle ആയതുകൊണ്ട് നമുക്ക് സർക്കിളിന്റെ സിലിണ്ടർ എടുക്കുമ്പോൾ സിലിണ്ടർ നമുക്ക് ആ ബൗണ്ടറി മാത്രം മതി. So the radius is there fixed. So here the radius is √7 but the angle will vary from 0 to 2 pi and the height also varies. നമുക്ക് സിലിണ്ടർ കിട്ടണമെങ്കിൽ z ന്റെ വാല്യൂ വേരി ചെയ്യണം. So here z is varying from 0 to 1. So hence using this idea we can form the parametric representation. So the parametric representation is, so x and y varies over this circle. So it will satisfy the equation √7 cos theta and √7 sin theta. So √7 cos theta whole square plus √7 sin theta whole square will be equal to 7. So that's the value of x and y. And then let us put z equal to z itself. അപ്പോൾ രണ്ട് parameters ആയിരിക്കും വരിക, theta and z. So theta will vary from 0 to 2 pi and z is varying from 0 to 1. So that is the parametric representation of the cylinder. And find the next problem is find the parametric equation for the portion of the plane x plus y equal to 2 that extends between the planes z equal to -1 and z equal to 1. So here also same, we'll use, so z varies from -1 to 1 and x and y varies over this plane x plus y equal to 2. So let me use the parameterization x equal to u, but that will give y equal to 2 minus u, and here z varies from z is equal to b. So z varies from -1 to 1, and here u will vary from, so you can take any this portion of the plane, that is an infinite portion of the plane, so you can take any value from -infinity to infinity. So that is the required equation for the surface. Let us consider a curve, let's say y equal to f of x about the x-axis. So suppose we are having a curve like this. So we have y equal to f of x. Now it is bounded by, say, some x equal to a and x equal to b. Now suppose it is revolved about the x-axis. So when you revolve about the x-axis, so we will get a surface. Now let us see how to represent this surface as a parametric surface. So here we have y equal to fx about x-axis, and it is revolved about the x-axis. Now if this is the case, then the parameterization of the surface will be given by x equal to u, and y will be given by f of u cos v, and the parameterization for z will be f of u sin v. So this is the parametric equation for the surface generated by revolving the plane curve y equal to fx about the x-axis. So we have x equal to u, y equal to f of u cos v, and z equal to f of u sin v. So let us see an example based on this. So find the parametric equation for the surface generated by revolving the curve y equal to sin x about x-axis. So here you have y equal to f of x. So f of x is equal to sin x. So therefore the parametric equation is given by x equal to u, y will be f of u cos v, and z will be f of u sin v. So upon substituting, that will give us, so x ന്റെ place u varum, and y will be f of u is sin u cos v, then z will be again sin u sin v. So that is the form of parameterization when you have a plane curve revolved about the x-axis. അപ്പോൾ കിട്ടുന്ന surface of revolution നമുക്ക് ഈ ഫോമിൽ represent ചെയ്യാൻ പറ്റും. And now let us look at the problems on finding the equation of the tangent plane. Now equation of the tangent plane, for finding the tangent plane, as we have seen, we need to find the normal vector. So normal vector will be ru cross rv by norm of ru cross rv, and this is the unit normal vector. The equation of the tangent plane will be x minus x naught, y minus y naught, z minus z naught dot n edukka equal to 0. So that will give the equation of the tangent plane. So let us see how to find the let us see examples on how to find the tangent planes. So you are given first the surface which is represented by x equal to u, y equal to v, and z equal to u square plus v square. For this surface, we need to find the equation of tangent plane at the point 1 to 5. ru R of u v എന്ന് പറയുന്നത് u v u square plus v square വരും. So first you need to find ru and rv. So take the partial derivative component wise with respect to u and v. So ru will be 1 0 2u, rv will be 0 1 2v. So take the cross product now. Cross product എടുക്കുമ്പോൾ you will get I into minus 2u വരും, then minus j 2v plus k 1. So that is minus 2u minus 2v 1. Now let us evaluate ru cross rv at the given point. So the given point is 1 to 5. അപ്പോൾ u ന്റെ value 1 വരും, v യുടെ value 2 ആയിരിക്കും. So ru cross rv will be minus 2, then minus 4, 1 വരും. Therefore, the absolute value norm will be root of minus 2 whole square plus minus 4 whole square plus 1. So that will be equal to, so the unit normal vector will be minus 2 minus 4, 1 by the magnitude. So that will be root 21. So this is going to be the unit normal vector. Now take the dot product with x minus 1. So we need to take x minus 1, y minus 2, z minus 5 dot n, so equal to 0. So when you take the dot product, root 21 will cancel off. So remaining you will get minus 2x plus 2 minus 4y plus 8 varum, then plus z minus 5. So upon simplifying we will get minus 2x minus 4y plus z plus 5 equal to 0. And another example is when you have r equal to u cos vi plus u sin vj plus vk, and we need to find the tangent plane when u is equal to 1 by 2 and v is equal to pi by 4. So let us find ru and rv. Ru will be cos v sin v 0, rv minus u sin v varum, u cos v 1. So when you take the cross product, ru cross rv will be, so write down the components, cross product edukka. So we will get I sin v, then minus j cos v varum plus k u cos square v plus u sin square v. So u into 1 varum. So therefore ru cross rv will be sin v, then sin v I minus cos v j plus u k. So that is the value of ru cross rv. Now substituting the value for u and v. So sin v will be sin pi by 4 cos pi by 4 1 by root 2 varum. So we will get 1 by root 2 I minus 1 by root 2 j plus 1 by 2 k. So now take the magnitude of the norm of ru cross rv will be root of 1 by 2 plus 1 by 2 plus 1 by 4. So which is root of, there's a small correction there, so we will get root 5 by 2. Root 5 by 2 varum. So that is going to be the value of n cap. And now let us substitute the value of u and v. So u is 1 by 2 and v is equal to 5 by 4. So the value of x naught, y naught, z naught is going to be equal to, for u v ഇവിടെ substitute ചെയ്യുക. അപ്പോൾ 1 by 2 root 2 വരും, here also 1 by 2 root 2 and 5 by 4. So that is the value of x naught, y naught, z naught. Let us now write the equation of the